video, we covered the notions of graphs and simplicial complexes. Now let's see what we can do with them. First, let's consider a simplified model of the internet. When you open a page, you are connecting to a physical server through the World Wide Web's network. Imagine for a second that all the information flowing from USA to Europe goes through a single oceanic cable. What would happen if this line is cut? As a European, you wouldn't be able to access a single page hosted in the US simply because there is no path to carry the information to you.
Where is my YouTube video?
In terms of graphs, we say that Europe and USA form two disconnected components. One can connect to any server within one continent, but there is no chance to have information flow through the Atlantic Ocean. The information about connected components of the graph is encoded in the zeroth homology group. Its rank, called beta 0, counts the number of connected components, which are 2 in our example. On your road, you might have encountered a pothole. It is a hole in the surface of the road. It's not the same type of hole as you've seen in the internet because you can still reach the other side of the road. However, there's still a hole, just not of the same nature. So we measure it with yet another tool, this time H1, the first homology. The more there are H1 holes, the more difficult it is to go from one side of the road to the other. The two sides of the road are now disconnected, and beta 0 is now worth 2. How do we measure the generalized notion of connectivity for a space? How can we efficiently identify and count holes in space? Homology is the tool you are looking for. Homology measures the failure of connectivity. As a network engineer, you're trying to connect everybody to the network. Translating that in homology, you must make sure that your zeroth homology, H0, is as small as possible. If you are a road engineer, you want to avoid potholes. So you want the first homology, H1, to be as small as possible. If you are a space engineer, you want to avoid black holes in your hyperspace route. So you want the second homology, H2, to be as small as possible. So, if you're a network, a road, or a future space engineer, you better keep those homology groups small for your routes to be efficient. Connectivity is a global property of your network. So the next time YouTube is down, it means that there is a hole in your network. Apart from when your router is bugging, this occurs only during global failures. Homology is that tool that efficiently describes all the problems we stated. It is used to assess what is left invariant after non-catastrophic modifications in your underlying space. Take these ideas a step further with Giotto by visiting our GitHub page. You will find there a package to do topological machine learning. Giotto is here to help you see in shapes, but it also needs your help. Show your love by giving us a star on our GitHub page.